this right here is the chassis from a console stereo. It's a Telefunken Concerto 5296 WK. It's not mine. So my channel originally was going to be about this, about pointing a camera at my bench and working on some piece of audio equipment and talking about what I'm finding and what I'm fixing and maybe how things work, and also maybe talking about some of my projects that I've built, tube amps and other stuff. But recently I've gotten into the vinyl community a little bit, and I met someone who's local here, and he had shown his console stereo. This is sort of a family heirloom, I guess, and he was hoping to get some help with it. So that's what I'm going to be doing today, or at least this is going to be the first step anyway. I think this is going to be a multi-part series. So this thing is, most of it is a tuner, so it does AM, it does shortwave, and it does FM. And not only does it do FM, but it does FM stereo. There's actually a separate demodulator, or demultiplexer, sorry, for stereo FM. That I was really surprised. That's kind of unusual to see. Doing stereo FM with tubes is no easy feat for sure. I'm not sure if I'm going to be able to get that to work, but we'll see. So the story is that this sort of used to work, didn't work well, and its owner, Jeff Kempen, and I'll leave a link to his VC channel, to the video where he talks about this. He attempted to rebuild it to some degree. It had a bunch of those old wax and foil capacitors that were looking leaky and scary, and so he replaced a bunch of those and replaced the rectifier on it, I guess, and yeah, and it hasn't worked since. So I'm gonna take a look at it and see if I can figure out what's going on with it. So here we go. So the first thing I want to do is protect all this fancy front here. I'm just going to pull off all these knobs. These old plastic can get brittle, and I don't want to stress any of it, so hopefully these will come off. There we go. Oh, look, they have metal clips. That's great. Set these aside. That one's not coming off. That one came off good. It's nice when they use these springs because it takes the stress off the plastic and it doesn't split the plastic. Oops. Not sure how these rings come off. That's interesting. This thing has a lot of interesting gizmos. I haven't quite figured it all out yet. Okay, whatever this is supposed to be turning, it's not turning it. And it's got a set screw right here. There we go. My goal is to get this glass off because I don't want to chip this glass. That's what I'm afraid of. Oh, this has a set screw. That's the problem. There we go. So look how nice they used to make these things. There's a set screw and a steel block for the screw to actually thread instead of trying to thread through the plastic. I used to engineer stuff back in the day. Well, that's German engineering, I guess, for you, right? Got a little felt pad here to protect the glass. Save that. Okay, so it looks like the glass will come off. Take those screws out. go. Here's the glass. Get this, put this in a safe spot. So notice this thing doesn't move real smooth. It kind of gets caught. Not sure what's getting caught on. Oh, it's getting caught on the paper. So this cardboard here is all warped, and it's catching the needle. It's got warped from heat. So this right here is a magic eye tube, they call it. It's a special tube with a phosphor coating on a plate in it. It'll show a green bar, and they use that for tuning and stuff. It'll be interesting to see if that works. Those are getting a little tough to find. I noticed this too. There's a little wheel here with a rubber band that's all dried up. Actually, this looks like this looks like somebody added this recently, because there's no way that a rubber band like this would survive this long. I don't think. But yeah, it just moves this little gate. I think it's just for there was a little like series of notes in the glass, and this probably just moves this for visual entertainment purposes, we'll say. I don't think these buttons come off, so I'll just leave those alone. Alright, time to get the camera out of the way and turn this thing around and start getting serious. Alright, so I'm looking at the power inlet arrangement here. So these two pins are where the power goes in, and there was a big fiberboard panel, and the power cord was riveted right to the panel when it, unplugged when you pulled the panel off. So I didn't want to drill the rivets out and take the cord, so I don't have a cord that's exactly like this, but I do have one of these handy universal power cords, or as my dad would call it, an idiot killer. So I'm looking at this terminal strip here, and it looks like this is how I got it. And I'm guessing this probably went here. So it looks like this is an unfused direct off the mains, and then this one is fused. So it goes to over here to the switches, and then back. And so these two yellow wires are the switched power, and they're going up to this panel here, and it goes through this fuse, which then goes down to the transformer and to this wire. So this was a fused AC mains, switched and fused. Oh yeah, okay, it's switched, got it. And this one's unswitched. Not sure what the reason for that is. One of these is for the turntable hookup. I would imagine it would be on the switch side. And you'd want the fuse protection too. I don't know what the unswitch would be for. Maybe an outlet or something? I have no idea. This looks like some lamp cord too, so I'm wondering if this is some sort of crazy retrofit deal. So anyway, I guess I'll look at the fuse first. It's really dirty. Can't really tell. It's a mini fuse, which is kind of surprising. Oh yeah, it's blown. So I don't know if you can see on the camera, but yeah, this fuse blew, which is a good thing. So if something went wrong with the rework that shorted out the power, the fuse was able to protect everything. So my concern was maybe that the transformer had a problem, which would be pretty much the end of the story. But chances are it's probably fine. So let's see, this is a 1 amp, 250 volts. Looks like a fast-acting fuse. It's kind of surprising. Right, so the fuse blew. So it could be for one of two reasons. I suppose it could have blown because of something that happened out here. That would have made a huge spark. I'm sure you would have seen something. So the other thing I'm a little suspicious about is the rectifier. So let's need to flip this over, but I don't want to break anything. I'm afraid of breaking these plastic buttons. I'm just going to take this board off. that's not a good idea. I'm going to put that back on. So the insulation on the power transformer leads is extremely brittle. Well, it may not be brittle, it may just be a lacquer. Okay, I was concerned that the insulation was cracking, but it might just be the lacquer that they dipped the transformer in having hardened. But I'm going to play it safe, and I'm going to leave that on there. I don't want to stress out this wire any more than I need to. Alright, so I'll have to figure out a different way to support this thing upside down. I'm going to sit on its back. Let's do that. So it seems pretty safe to lay on its back like this, so I think this is how I'm going to work on it. What I need to get under here. So my suspicion is that we have an issue over here with this solid state rectifier. So there used to be a large module here that I'm guessing was probably a selenium bridge rectifier, and it's now has a just a silicon one that you can get at Radio Shack or wherever. I'm noticing how close these pins are to the bracket here. I wonder if it's shorted. That could have been what blew the fuse. So what I'm going to do is I'm going to desolder the transformer from this bridge rectifier here, and we'll bring up the transformer slowly and make sure it's okay, and we'll go from there. Some very crispy wires. These wires are straight off the transformer here. You can see it's just the transformer winding in an insulated jacket. Alright, so the transformer is disconnected now. Alright, so this was a 47 microfarad, 350 volts, going from chassis to these two yellow wires here. So this is the 100 microfarad, 350 volts. This is what's across the rectifier. And this is the only path to... Oh no, it's grounded right here. Okay, yeah, that would have been... That's fine. Alright, I get it. Ah, the smell of ancient solder. Or ancient flux, I should say. cut this. Alright, BR8. Okay, so this is, from what I can tell, it's a VE48, which is, I believe, a 400 volt PIV bridge rectifier. Gonna need to be more like 800 volts for this application. It needs to be, for a bridge, it always needs to be double. So, I don't know if this is blown or not. Be interesting to see. But anyway, so we got the bridge rectifier out. These are the AC from the transformer here. Alright, got the caps removed as well. Nice, so I pulled these wires off the terminal strip. Which are a little heavy duty for what we're doing here. So the two wires from down there came up here. One went to this 1K resistor, and the other one went to this one here, which goes into into the output transformer. Again, these wires are very brittle. Oh, we got a broken wire here. A couple of them. So yeah, have to figure that out. Okay, so we're topside again. I've pulled the high voltage primary wires from the transformer out up here so I can attach my meter to them. I have my universal idiot killer connected to the primary side. I'm just bypassing the fuse and then plugged into my Variac here. So the way I like to do this is, this Variac takes a 12 amp fuse, but I just put like a 1 amp fuse in there, and that's what I use as my protection for everything. So if something goes wrong, it'll blow this fuse. And I'm still going to bring it up slowly on the Variac, even though there's no DC. So what I should see is my high voltage. If these bulbs aren't burned out, I should see them light up, and the tubes, I should see the tube heaters also light up. I just left the tubes in for now. There's no high voltage anywhere. So there's no danger of hurting anything. So let's see what happens. Well, I got a volt there, so that's a good sign. As you can see, it's coming up. Bring it up to about 25%. The lights are coming on. So these two lamps behind the glass are lighting up. Looking at the tube heaters, I don't see any evidence of the tube heaters yet, but it may not be enough voltage yet. So let's turn it up a little more. So about 50% now. Alright, so I'm seeing the heaters now on the amplifier tubes there. I see a heater over here. They're all connected together, so I think that winding is good. The lamps are on. And we got 150 volts at 50%, so let's turn it all the way up. There we go, I got 250 with no load. Lights are on. Heaters are on. So yeah, transformer's good. That's good news. Let's check this bridge rectifier. Yeah, it's blown. So this is blown. So I need to build a new bridge for this. That won't be a problem. I think I'm going to make something a little bit nicer than that package deal. So one thing about new versus old rectifiers, I'm actually not too familiar with selenium rectifiers. Those were sort of early solid state ones. But modern silicon rectifiers can be a little noisy, unexpectedly noisy. When I've retrofitted some equipment, sometimes the switching noise of those diodes creates noise in the circuit that wasn't there with an old tube rectifier, and that's just because a tube rectifier has sort of a soft start-stop to it, whereas a solid-state one is much more quick. So I'm not sure about a selenium one, but anyway, I'll build something with some Schottky diodes so that it'll be nice and quiet. So something else I want to look at are some broken wires here. So these are coming off this output transformer. They're very delicate. They didn't put any stranded wire on their transformers at all. It doesn't look like. They just took the winding off the transformer, just came straight out, which means you have a very small solid conductor, and they're very frail. I've bent them a few times and they break. In fact, this one here is ready to break, I can just tell. So these broke probably when he was working on this. So these are the replacement capacitors, which I haven't looked at the values, but they look fine. I'll double check all the values though. So yeah, trying to pull this board out and desolder everything, just moving it around probably broke off these guys. So I have to figure out what these are. The colors are so burnt from age and heat that I can't tell what they are. This one's got stripes. Let's see what the schematic says. So this is supposed to be green. See how they're all brown? Okay, so I've just been spending some time looking closely at what's going on under here. So we know the transformer's good, so that's good news. The rectifier was blown. Not sure why. Could have been because it was shorted against the bracket here. Could have been overloaded because I don't think it needs to have a higher PIV rating. So that's probably what blew the fuse, I'm guessing, was the rectifier. And I think it might have been a blessing in disguise, because there's some things that are a little bit risky on this thing. So like this lead right here is almost touching the chassis. It's grounded on this end, but this, I'm not sure what part of the circuit this is, but I have to look. I don't know if this is sticking up too high. Seems like it might be. Don't want to break this terminal strip here. Kind of worried about some of the clearances here. This guy's not connected. I'm not sure what it's supposed to be connected to. But I'm looking at this one. Looks like it goes to ground. This one might need to be switched, put the other direction. So yeah, so I'm just going to go through this very slowly and make sure everything looks good, and just follow the circuit and try to make sure that everything is connected the way it should. Here's another close call right here. These two guys are touching. This capacitor is touching this terminal here. Just going to spend some quality time with this. I'm not going to film it because it'll be super boring. Replace some of these old wires probably. We'll fix the broken wires here. I should be able to figure that out. I can't tell what color any of these wires are anymore because they've all turned to brown. But try to figure that out. Yeah, I need to look at those original pictures before the work was done, so I can kind of double check some things. Because boy, following the schematic on a point-to-point like this can be a real challenge, because the physical position of the part on the chassis oftentimes has no correlation to its position on the schematic in terms of how far the parts are apart. Next will be just a very slow and deliberate sort of inspection of the circuitry here and just make sure that everything is connected the way it should be, and check the values of all these caps, make sure they're good. I'm looking at them and they look like they're probably fine, but we'll double check that. And I might replace these guys because these are, I'm guessing these are probably the coupling or the bypass caps for the cathodes. So want to use a good cap for that, so I've got some good caps that'll work well there. And I am guessing the coupling caps are one of these guys as well, so we'll check those. These are probably fine for that, but if I have something better, I'll swap those out too. So yeah, I'm hoping that the rectifier took out the fuse and just sort of stopped things right there, dead, and nothing else got damaged in any way, especially the tubes. Alright, so we'll pick this up again.